Okay, this is Dr. Williamson doing this problem. Says the rate constant of a reaction is 43.7 times 10 to the negative third seconds to minus 1 at 25. Activation energy is 44.6 kilojoules per mole. What is the rate constant at 85? The equation we're used to is this one. What I did is exponentiated both sides and solved for K2. I get this form. This is going to give me here equals 43.7 times 10 to the negative 3 seconds to the minus 1 e to the minus 44.6 kilojoules per mole is going to be 44.6 times 10 to the third joules per mole. I know it's sloppy, guys. Divided by 8.314 joules per mole Kelvin per mole. I know it's real sloppy. Times 1 over T2. 85 Kelvin is 358. Excuse me, 85 Celsius is 358 Kelvin. Minus 1 over 25 Celsius is 298 Kelvin. This is Kelvin. When I subtract these two, I get 0.0000562 Kelvin to the negative 1, and it's actually a negative number. And so now I've got to multiply this negative number times 44.6 times 10 to the third, or 44.6 thousand. Divide that by this. So let's go here, 44.6 thousand times 0.000562 divided by 8.314, and I think I did something wrong here. 44.6 times 1,000 times 0.123562 divided by 8.314. I get 3.01. So I'm going to have equals K2 is equal to 443.7 times 10 to the minus 3 seconds to the minus 1 e to the positive, because I have this negative and this negative. And I'm going to have basically 3.01, right? Some of you guys might get 3.02, but right, try and get this on my calculator. So let's go e to the 3.01. That's going to give me 20.2. Multiply that by 43.7. And if I did it right, I might have made a mistake because I'm using my cell phone calculator. I'm getting 0.887 seconds to the minus 1. So I hope I did it right. K2 is equal to 0.887 reciprocal seconds. It went in the right direction. It got bigger, which is what I expect the rate constant to do with increasing temperature. Okay. If I got the wrong number here, it's probably because with my cell phone calculator, I punched in the wrong number the wrong way. But what I did is I took this equation, turned it into this one by exponentiating both sides and solving for K2. Substituted in the value of K1 right here. Substituted in EA, but I turned it into joules per mole. So 44.6 kilojoules per mole is 44.6 times 10 to the third joules per mole. I did that because then R is 8.314 joules per mole per Kelvin. The joules per mole here will cancel. This 1 over Kelvin will cancel with these 1 over Kelvins, right? Cancel with that. So I end up with e to the positive, the minus and that minus cancel. E to the positive, 44.6 times 10 to the third, times 0.000562. That divided by 8.314. I got e to the positive 3.01. When I did that, e to the positive 3.01, I got like 20.28. And so this is about 20.28 times this gave me 0.887. So I believe that K2 is 0.887 if I didn't make a math mistake crunching it into my calculator. Okay, anyway, I hope that helps. And if I did make a math mistake, please put a comment in the YouTube video and let me know. Okay, then.